Gadzometer had asked a question about whether or not the comet that is associated with this sunspot will be visible on the SOHO feeds. And that really depends on its trajectory. It depends on the direction that it's coming in to the Earth. And if you were interested in looking for objects, I'll put a link in the comments for this site. It's called Earth's Busy Neighborhood. It's a traffic report, and it shows the objects that are being tracked currently that are in the Earth's proximity. And there's a list down here at the bottom. If you look at the list right now, there's several objects that could be responsible for this sunspot. And it could be also be that these objects are the pieces of the sunspot. And if you look at the distance, this one will be 2.64 lunar distances on October 21st. It really doesn't tell us how close it's going to come to the sun, so we really don't know whether that will be visible in SOHO or not. But there's several of them right now that fall into this situation that are, inside the or are going to be inside the Earth's orbit. And so you've got these objects. They're fairly small objects, and to really understand, if you really want to understand how such a small object could cause feedback it could cause this object this formation on the sun, then you have to understand how it creates feedback in the common carrier in astrotometry. You have to understand the nature of the magnetic force. You have to understand the nature of the interplanetary magnetic force. And so here's another one, 7 lunar distances. This is well within the Earth-Sun orbit by the 25th. More likely it's something like this down here that will be the closest on November 1st. These are the closest approach to Earth is what they're interested in here, which is a fairly significant thing to want to track. I guess it's the important part from the perspective of a project like this. But it doesn't say how close they're going to be to the sun. And so if there is a coronal mass ejection, like was seen when Comet Neat approached the sun, if there is a coronal mass ejection, then the comet will be visible. It's not going to be a comet of this size. There's no way that if it was this size, we would have already seen it by now. It's probably a much smaller object. But these regions, these coronal features do not always associate with a coronal mass ejection. And so you can have a sunspot, you can have this sort of spot on the sun and not see a coronal mass ejection from it. And so that sort of trajectory is a sort of one that is non-destructive, I guess you might say, if it actually makes it back out of the solar system. But the issue is the consistency of the orbit in astrotometry. The thing that I've identified that is the difference between an object that will make a mark, will create an active region, will create a spot, and one that will not, is its orbital consistency, its velocity, and the circularity of its orbit, in a sense, with respect to the apparent circularity of the Earth's orbit. And so there's this, I'll get into the models of hypertime, the details about the wave mechanical possibilities of how to treat that at a later time. But at this point, suffice it to say that what is up there is not what it looks like.